Hello friends, in this video lecture, we will see problem based on shortest remaining time first scheduling algorithm, which was asked in GATE 2006 examination. And the problem is, consider 3 CPU intensive processes which require 10, 20, 30 time units and arrive at times 0, 2 and 6 respectively. How many context switches are needed if the operating system implements shortest remaining time first scheduling algorithm? Do not count context switches at time 0 and at the end. And there are 4 options: 1, 2, 3 and 4. To solve this problem, we have to understand the meaning of context switch first. So what is context switch? It is a mechanism to store and restore the state or context of CPU in PCB, that is process control block, so that the process of execution can be resumed from the same point at later time. That is context switch. Means when CPU switches from one process to another process, the process from which CPU switches, the state of that process is stored there in PCB, and later time that state of the process will be resumed at the same point. That is the context switching. So we have from one table showing 3 processes, process P1, P2, P3, arrive at 0, 2 and 6, and burst time for process P1 is 10, for P2 it is 20 and for P3 it is 30. Let's sketch the NAT chart first. Here we have to follow shortest remaining time first scheduling algorithm. So at 0, ready queue will have process P1 which require 10 units to complete. So process P1 will hold CPU for unit time 2. Means at 2, process P1, which is running process, require 8 units to complete. Process P2 requires 20 units to complete. Here P1's remaining time is 8, means P1 will continue to execute. For how much time? Up to 6, that is 4. Means at 6, process P1 requires 4 units to complete, that is remaining time. P2 requires 20 and P3 requires 30, which is another new process. So here, because of shortest remaining time first scheduling algorithm, P1 will continue to execute. So P1 will have CPU till its completion, that is 4, means total time is 10. Now after P1, there is a switching of CPU from this process, that is P1 to P2, because P2's remaining time is less than the remaining time of P3. So P2 will hold CPU for 20. So total time is 30. And after P2, P3 will hold CPU for 30. So total time is 60. So here we need one context switch at the beginning. Then process P1 has CPU for unit time 10. And at 10, CPU switches from process P1 to P2. Then at 30, there is a switching of CPU from process P2 to P3. And at the end, there is one more switch. Means we need 1, 2, 3, 4 switches. And what was given in the problem? That do not count the context switches at time 0 and at the end. Means here it was given there in the problem that do not count switches at the beginning and at the end. Means total switches are 2. So answer is 2 here. Number of context switches needed here is 2. Thank you for watching. For more such videos, stay connected here with this channel.